Hi guys, I'm Xavier from Primus. Today I would like to introduce how to create a verifiable agent on the Eliza with Primus zkTLS. And these are the key steps of outlines of today. So first I will introduce a bit about Eliza, how to set up. And the next step is how we need to configure the Primus plugin to enable the verifiable agent features. So then we run some demo to show different um, private providers and actions and how we can enable the verifiable feature on that operation. And the last thing is I will mention about how we can verify this thing on the blockchain. So right. Before I go to the details, I need to give a bit of knowledge about the zkTLS. So, zkTLS actually is kind of web data verification technology that can bring the Web 2 data into Web 3. And in technically, it just uh, trying to prove the web data response, the correctness of the web response through the TLS protocol. Just imagine if you are a Web2 user, you have some private data on the web server and how you can prove with that. Basically, you need some endorsement or signature created by the server, and you'll share this data to the third party. But this will engage with a lot of complexity with the data server side. And the zkTLS makes a new approach that it's using a third-party role called attester, and this attester is always monitoring the TLS traffic between the data client and the data server. However, he has no way to see the raw data because all the TLS data communications are encrypted. So only the data user and the data owner and the web server knows these encryption keys. So the KTS using some advanced technology like zero-knowledge proofs or multi-party computation to ensure the correctness of this encrypted data is from that server. So it's kind of very generic technology that can prove the status or prove the correctness of API calls. So which will give us the capabilities that we can prove the operations of agent activity. Just to remember, using some LLM, a large language model, or take some action, or using some providers are always API calls, and you can always use the zkTLS to prove that. Um, right. So let's get started. Um, so this is Eliza documentation, and I strongly stress you to follow the quick start guide here. So like you can git clone the Eliza repo, you can check out with a stable version, and you can install and you build with the repo. Since I'm already done with that, um, so um, since I'm already built with that, let me show you how we need to configure the Primus plugin. If you're using the IDE to open this Eliza framework, you can see in the packages folder, there's a plugin called Primus here, and I stress you to check with the Primus plugin README here. You just follow the Eliza repo, and in the packages, there's a plugin Primus folder, and this is README here. So it gives you some context information about what Primus and what zkTLS does. And there's essential information here, like you need to install that plugin. But since if you already download git clone the whole repo, you don't need to redo that. And the configuration need information like you need to add this environments variable to your env file. And the question is how you can get this Apple ID and app secret. Um, it's very simple. You just visit the Primus park here. You create a new project and then you save that to data into your env file. So let's do it. Let's do it. So you just found there's a new project here, and you click it, and then you give some random names here, like Eliza test, and since it's backend integration, which means you'll need the Eliza agent to run the zkTLS always for you. So you'll give it an for backend option, and you create. And then here you can see these two applied and secret value here. You simply copy these two in your .env file. Just remember this is your uh, configuration file within the Eliza folder, and you copy these two value here. And the next thing is you need to configure the plugin premise value in your character file. So for me, I using the Trump character file here in the JSON file. So you just simply import the plugin premise data in your character JSON file to enable this feature. So basically, this is the two key options, and then you can just run the server and run the client. So since I already done with the configuration, so before we go to the uh, demo, I would like to introduce a bit about what the premise action does. So basically, there's a premise adapter, and it will call the OpenAI model. And if you want to using a different model, you just configure here. You can make a new case switch here. Just remember, you already configure a very correct API endpoint to make sure that the model response will return the same thing. And um, so basically, this zkTLS will prove that we call a correct OpenAI URL. And also in our action, we provide a post tweet action, and we check this action file here. So the key thing he do is so first he will run the token price provider, trying to get some Bitcoin price from the Binance exchange, and they will return that. And just remember, we run some zkTLS proof within that token price provider. So let's check the code here. This is uh, something he visit the price URL, the API from the Binance, and he trying to generate the proof and verifies that proof uh, as a meanwhile. And this is some cool interfaces we used from the Primus zkTLS core SDK, and it will return the data. So after that, this action will trying to make a new tweet, send the Twitter to the with that content with the price data. And check it again. We check this send Twitter. You can see there's a lot of details, but again, we also create some proof and then we further verify that proof. So this means we do every uh, verification on every operations of the agent. So yeah, let's start. So first, let's start the server. And remember, we need another terminal to start the client. So since I already start with that, so just keep that. And take several seconds to start server. Um, okay. Now you can access your agent at this URL. Let's see, access that. Okay. Right. One thing I need to indicate is you need to prepare an automated tweet account because action makes that agent to make a new tweet for you. So you need to configure a new Twitter account and mark it as an automated. Uh, like me, I already created a Twitter bot account here. I'm already marked as an automated. Be remember to mark it Otherwise, just take care that your account will be blocked by the Twitter. So let's run some give some promotion here. Get the latest price of BTC and post it in my Twitter. Right. Um. Right. Let's see. Execution the handler. Basically, the agent will first get the price, and then also you can see there's a TS proof. So this is some price called price attestation. Looks like it already gets price data, 97334 here. And also, meanwhile, we created the zkTLS proof, oops, proofs here. So this is signature and this is some attestation metadata already verified. And then now next is we trying to send a Twitter and this this are the attestation, the proof data generated within the sending Twitter action. So already sent with the Twitter ID. And then now let's visit the my Twitter account and then let's refresh that. Right. Okay. Just a 1 minute ago, there's a new Twitter. Get a BTC price from Binance. The data here posted by Eliza, attested by Primus. So it looks like done. All right. So yeah, this is pretty much about you can post a Twitter and you're using the uh, token price provider here. And of course, you can switch to a different provider. So the idea is you just simply define your own provider within the providers folder and you configure it here. You can just using a different provider. So for me, I simply switch to the Twitter provider. So it gets some Twitter from a Twitter user if you want to indicate. And just remember you configure some Twitter username in your env file. And if you want to do some other thing, for example, if you want to um, get some weather data or get some uh, public data from some Web2 platform, just simply do that. And just make sure you always um, call that Closer zkTLS joined proof and the verified proof. So it within your uh, provider code. So yeah, I think this is pretty much about how you can configure with your customized agent. And yeah, so yeah, and last thing is about how you can verify the proof on chain. It's very simple. If you check that premise doc and you can see there's a some already deployed contract either on the Solidity. Also, there's some contract deployed on the Sui network, and you can check it on the Primus Labs GitHub. There's a zkTLS Sui contracts repo which is public, and okay, you using that as a zkTLS move contract to do with that. And the key idea is um, you need to integrate this essential code. So because all the attestation data can be submitted to the blockchain, and you call this verified signature interface within your specific contract, and you're using that import accession data, and you can using some other contract to process with that verification if it's true or false. So both the Solidity contract and the uh, and, and, and and the Moon contract are done with the same thing. So it's very simple. You just verify the attestation using our contract functions, and then you process with your own business logic. And we already deploy this um, this contract on EV and blockchain, like a lot of layer twos here, and also we deploy it on the three. So yeah, this is pretty much how you can verify your proof on chain. And there, if you have further questions, you can check our Primus plugin information in this branch, and also check out tech docs here. And you can contact me through the Twitter with my Twitter username here. So yeah, so thanks for watching.